This is a tutorial about the blood flow around the heart and around the body, and it's aimed at level 3 students. This is part of the cardiovascular system, which you have been learning about. Every cell in the body requires oxygen, so every single cell requires this oxygen, and the role of the blood is to deliver that oxygen. I'll start off by explaining this, okay? We refer to the body, specifically the heart, as having a left and a right side. It is the opposite to your left and right side because it's about a reflection, like a mirror image. So this is my right side, but I will refer to the parts of the heart on that side as left. My left side, that part of the heart then is the right side. So this happens in diagrams. So when you're Google searching images and you come up with the heart, left is right and right is left. So we'll start off with the pulmonary cycle, the pulmonary circuit. What is it? Okay, there are 3 circuits of blood, cycles of blood. This one we'll look at first. Pulmo is Latin word for lungs. You may have heard of COPD, okay, pulmonary disease, the P being the pulmonary. You may not have heard of it, of course. So the pulmonary cycle is responsible for collecting oxygen, and it's a constant cycle of blood flowing from the heart to the lungs and back to the heart. So if we have a look at it here, and I'll cover up bits to not confuse you. Okay, so the heart doesn't just pump blood around the body. What it's actually doing is a figure of 8. It's going up to the top and around to the bottom. We're looking at the first one, the pulmonary circuit. So as I've just explained, the heart will pump blood up to the lungs and then bring it back to the heart. So that's a fairly small circuit for it to do. And the reason why it's doing it is that it needs to collect oxygen. Remember, every cell in the body needs oxygen, and deliver it back to the heart. So that is the pulmonary circuit, pulmonary being the lungs. Okay, that's explaining the pulmonary cycle then. So deoxygenated blood in diagrams is usually coloured a bit of blue colour. The reason for that is deoxygenated blood is actually slightly different colour to oxygenated blood. It's not blue like this, but it's a little bit of a tinge of blue, so that's why it's coloured like that. So blood from the heart up to the lungs and back down, collecting the oxygen, is the pulmonary cycle. This is a lovely stress ball of the heart, and if you listen to the heart, it's not just a heartbeat, 1, 2, 3. It actually does lub-dub, 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 because there is a contraction of the top of the heart followed by a contraction of the bottom of the heart with every heartbeat. So the blood would be coming in, there's a contraction at the top, the contraction at the bottom will send the blood up to the lungs, and this figure of 8 starts to happen. So this bit here is quite a short journey. In actual fact, the heart is sitting here at the bottom of the left lung. So the circuit is very small and the pressure of the blood going up there is a lot less than the pressure in the systemic circuit. Let's have a look at this. What is this systemic cycle, the circuit there? And that is the heart doing the bottom of the figure of the 8, pumping the blood that's got oxygen in it to every single cell in the body, and then taking it back into the heart without the oxygen in, to then do the pulmonary circuit up to the lungs, collect the oxygen and back down. So this is constant cycle, and it's about taking oxygenated blood to every cell and then bringing back carbon dioxide, which is the other gas that our blood is transporting back to the lungs to be exhaled out. So remember, this is happening, lub-dub, lub-dub, lub-dub. And we're looking at the different sides of the heart. Okay, this is the left-hand side. Okay, and this is the right-hand side of the heart. So we'll look at that in a bit more detail. the force of the blood coming from the left-hand side is a lot more under pressure because it's got to take it to the rest of the body than the pressure that is the blood then coming from the right-hand side going up to the lungs to collect that blood. So when we look at a heart, we are looking at it at two sides, and it's usually coloured in red and blue to highlight the fact that this is deoxygenated blood coming back from the body that then needs to go up to the lungs, and then the red side of it is that oxygenated blood that needs to go around to the rest of the body. So we will look at the final circuit, which is the cardiac cycle. This is the blood flowing as it enters the heart. In fact, it put simply, this is the directional flow of the blood through the heart from it entering to it accessing. So this is a process. So when you're revising, it's a step-by-step flow. Looking at the start, the blood entering the heart, right to the bit where it then leaves the heart. That's the cardiac cycle. I think I might draw it here, if I can find it. Okay, so we're going to now look at, move that out of the way, the cardiac cycle and stroke volume, which I'll explain that bit. We're going to look at this bit to start off with. I think I'll move that image here. Okay, so this is a picture of the heart. Okay, and remember, you have a left and a right side of the mirror image. Okay, so the blood entering the heart is coming back from the rest of the body. It's deoxygenated, slightly different colour because it's carrying less oxygen and carbon dioxide. So diagrams will show this as blue and red. So it arrives through the heart through entrances called sorry, that was a U. It's coming through these two. Okay, so it's entering through the superior vena cava, and this is coming back, that systemic cycle, the circuit coming back from the upper parts of the body, so the brain and the heart, it's coming back into the heart, sorry. And the inferior vena cava, that is blood that's coming from the lower part of the torso, the middle and the lower part of the body. So it's coming in here. So I will colour that in blue because it's that deoxygenated blood. So it's coming in here, and this will join it in the back of this into this bit here. Okay. Now, how are you going to remember these? I've spelt it cava there. This is how I remember, okay? There is sparkling wine. It's called cava. Okay, so you've got the vena cava, inferior and superior, and this is the blood arriving. Yay, it's arriving back. So I remember it as an older lady as sparkling wine. Okay, so the blood then enters into the right atrium. Okay, this is the right atrium here. So the deoxygenated blood arrives in this area, forcing into here, coming into these from the vena cava. Okay, the word atrium. Okay, the word atrium, it originates from a word about an entrance hall or a courtyard. So it's coming in, the atrium, the hall, okay. And I remember it as the blood arriving. So if I underline that A, okay, the blood arrives coming in. Remember, we need to know this process, a cycle, through the right atrium. So atrium begins with A, the blood then arrives. Okay, what then happens? Remember, lub-dub, lub-dub, lub-dub. the top part, the atria, contract. This forces the blood through this gate into this bottom area. Okay, the gate then shuts behind it, so there is no backflow. So the blood is coming to here, it can't flow backwards. It's coming into this area here, which is a bit bigger than the atrium. It's still that deoxygenated blood. And this is then called okay, this is the right ventricle. V. For me, this is where the blood vacates, leaves the heart. So you have the V, you have the A. Right ventricle, the blood is going to go out of the heart. Okay, so let's have a look at this in a bit more detail. The blood from the right atrium opens when it pushes its way through that contraction and then shuts. It shuts so there's no blood flowing back. Okay, open and shut with each heartbeat, open and shut, so that the blood isn't going back, it's simply going that one way. Now that is actually called the tricuspid valve. I'm not expecting you to tricuspid. Remember all of this first time round, which is why you need to watch the video again, watch other YouTube clips, and after a while it will sink in and it will come together for you. So don't worry that this looks a little bit complicated. Over time you will understand it. Okay, so the gate's shut and that's the tricuspid valve. You've got your V for ventricle, vacating, and your A for atrium. So the lower part of the heart then contracts. The first and the right ventricle then contracts and it forces the blood out here. Okay, the pulmonary artery. So it goes out, there's my blue pen, out this way to the pulmonary artery, where it is then pumped up to the heart. And there is a second gate there, as you can see, there's a second gate there, and that is called the pulmonary valve. Okay, I'll mark it up here. Okay, pulmo being going up to the lungs, the pulmonary artery. And again, there's no backflow of that blood. So it's going a direction and there is no backflow because that would cause extra stress on the heart. So this is the start then of that pulmonary circuit, up to the heart, come back, up to the heart and come back. So this is the start of it. Okay, it needs to go and collect oxygen from the lungs and drop off the carbon dioxide to the little tiny air sacs that are in the lungs, which of course is about collecting that oxygen to send it round to the rest of the body. Now let's have a look. The blood then coming back down from the lungs, having collected it, is coming into this side, okay? And we'll colour it with red so that we have the blood coming back that is now collected that oxygen from the lungs, and this one then is the left atrium. All right, so that is the hallway, the entrance into the heart, the left atrium, the blood is arriving. The heart then will contract at the top, forcing that blood through this gate that will shut behind it. And that is then in this bit here, which is called the left ventricle. Okay, so you've got the right ventricle, the left ventricle, you've got the right atrium, you've got the left atrium, which is not your left and right. The gate shut. This gate is called, I'll put it back down here. the bicuspid valve. I will put in brackets. It is also called the mitral valve, and it shuts to stop that black backflow. If it didn't shut, there would be extra pressure and hard work for the heart then to work even harder to get it out to the rest of the body. So this diagram shows it a bit. If we look here, the muscles here on this side of the heart have got to be bigger and stronger because they're sending the blood on that systemic circuit to every cell in the body. This one less so in terms of thickness because it's sending it up to the lungs, which aren't too far away, and then back into the heart. Your job is to revise these different parts of the heart because you can only talk about the cardiac cycle if you know the different parts of the heart, and later on you will need to know the different contractions and how they are controlled, the nerves that control that flow of the heart. So you need to revise all these, and again you can do that in different ways. So you may want to draw yourself. I've got one here. Yeah, you may want to draw the blood through here, flowing through the heart. You may want to do a flow chart. This is what I've done here. Okay, so if we just follow this through again, if you're thinking, oh my gosh, that is really complicated, over time it will make sense, so don't worry about that. Blood is coming from the superior vena cava, without the R in it, the inferior vena cava into the heart, the right atrium, arriving in the right hand side, not your left, okay? It is being squashed and sent through the tricuspid valve to the right ventricle. So it's coming through here, atrium, ventricle. It's then another contraction and it will go out through the pulmonary valve and then along through the pulmonary artery there. It then collects the oxygen at the lungs. So this is represented here as the gaseous exchange. It comes back through the pulmonary vein and into the left atrium, that entrance back arriving. It is then another heartbeat. It will come through into the left ventricle. This one here says mitral valve. It could be bicuspid valve. They're called the same thing. And again, that is forced out. The muscle is bigger here, forced out through the aortic valve to the rest of the body. I have put it, this is quite a good YouTube clip, but there are other YouTube clips to help you revise this cardiac cycle. Okay, you need to know the journey. You need to perhaps narrate that journey so that you are able to then answer questions confidently about it. While we are talking about the heart, we will then have a look at a couple of issues. Okay, what is stroke volume? So this is the amount of blood which enters the left ventricle and is then pumped out. Where's my diagram? So we're looking at the blood in here that is then pumped out. So that is stroke volume. However, stroke volume index is a measurement that measures that amount of blood and then it is measured against the body surface area. So a stroke volume in an adult, this bit here, is going to be bigger than a child. Okay, theirs will be a lot smaller, their heart's smaller. However, the stroke volume index is about that measurement to the size of the body, so the body surface. So then it brings it back into proportion. Okay, that explains the stroke volume, I think. Now, one other thing. How does this all work? Okay. There's a part of the brain, the medulla, that has receptors that can monitor the level of carbon dioxide in the blood because it's blood flow through there. It detects how much it is. It sends a message then for biochemicals for the adrenal glands to send a message to speed up or slow down that heart, so that cardiac cycle, the muscle contractions, and this is how this is regulated. It's a wonderful, very, very clever thing. Finally, let's just have a little look at these. Okay, so this one first. So tricuspid valve here. This is working fine, this gate, not a problem at all, but you can imagine there's an awful lot of force in this gate to make it open and shut. So occasionally when somebody perhaps has high blood pressure or another health condition, it puts quite a strain on that, and it can leave this as an issue. So you get a much bigger enlarged right atrium. These are working a little bit, but not that much. You get a much smaller right ventricle, so the blood is struggling to get up. So that person would be dizzy. They may even require a wheelchair to use, but what they will require is an operation to repair that, which is the picture underneath here. Okay, the tricuspid, 1, 2, 3, has got 3 bits that are shutting as a gate. I've put here the Roman god of love is called Cupid, and it fires on Valentine's Day, fires an arrow through a heart. Okay, so the tri is the 3 and the cuspid. Hopefully that will help you remember that. So an operation will then replace or repair so that somebody then can have a much better quality of life, extended life, because you can imagine the stress that this puts on the heart. It's having to work excessively hard. Those valves and those gates are there for a purpose. The same then if there's something goes wrong with this mitral valve, which is working even harder than this one here. The blood flow, if it starts coming back, the person is really struggling then. So I've put their mitral valve, but then it's bicuspid valve. But you need to know all of these. Now, funnily enough, when I looked up mitral, it actually says the bishop's hat is called a mitra, and that's what it's named after, but I just can't see it myself. Just can't see it at all. So if we go back to what you need to do to revise, to remember this, so we looked at the pulmonary circuit. Okay, so you now know what the pulmonary circuit is. We looked at the systemic cycle. Okay, so you now know that's to the rest of the body. The cardiac cycle, this is happening there. And then we looked at the stroke volume. So I suggest you come up with your own ways of remembering these cycles, remembering the words in it, so that you're able to answer an exam. So you've got it put simply just here, but if you then revise and revise, it will then make sense, and you will be able to show your knowledge of the cardiac cycle, the systemic cycle with circuit, the pulmonary circuit, and then what stroke volume is. Finally, let me find the sheet here. Other ways of helping you to revise is visiting the shop here. If you put in here what you're looking for, like the cardiovascular cycle, and there are other videos because you're learning about anatomy and physiology that you'll find very useful. Okay, so hopefully that goes some way to help you answer questions to do with the cardiac cycle.